Okay, good afternoon, class. So today we're looking at exponents of chapter 3, which is exercise 2. So today we're going to look at division. Alright, so yesterday our lesson was fairly long. We're looking at multiplication. Now we're going to look at the examples for exercise 2. And this one, example, also on page 29, if I'm not mistaken. The 30. Yeah, 30. Okay, so today we're going to look at division. Okay, so if you are given, for argument's sake, if you are given x to the exponent 5 divided by x to the exponent 3. So x to the exponent 5 can be written as x times x times x times x times x. 5 of them, not some. X to the exponent 3, x times x times x. There are 3 x's. Now, x goes into x once, x goes into x once. The x cancels x, the x cancels x as well. So what do we left with? X times x. And what's x times x? X squared. Not so. Now you do the same for this one. Let's say we got 2x 7 over 4x 5. Make it 3. 4. Do that sum quickly. Yes, Michael.
So how do we do 2 divided by 4?
Yeah, we not done fractions, Michael? 2 goes into 2 once, 2 goes into 4.
So do we do 1
1 over 2. Now, how many x's do we have in the numerator? 7. So it's 1, 2, 3, 4, 5, 6, 7 x's. Not so. How many x's do we have in the denominator? 4. 1, 2, 3, 4.
Okay, so much because if there's a numerical factor, then I suppose divide that as usual.
Yeah, as usual, yeah.
We do, okay.
That's correct. So what can happen here, people? X cancels x. Not so. Or x goes into x once, x goes into x once. X goes into x once, x goes into x once. X goes into x once, x goes into x once. So what are we left with? We have x times x times x. And what's x times x times x? X cubed. Can you all see that, people? So it's 1 x cubed over. Did I need to write that 1 there? Did I need to write this 1? Okay. Give the last, another example as the last one now, and then we're going to look at the rule. Okay. What have you got? 5 or 15 over 20 x to the 6 y to the 3 z over x to the 3 y 2 z. Yes? I thought you were going to ask me something mathematical. Very quick. I'm going to see when you're gone. Very quick. Guys finish? You're sleeping. Huh? Your eyes is closed. No, my eyes is lying. Okay. Alright, so what can we do first? What number goes into 15 and into 20 without the remainder? 5. 5 going to 15? 3 times. 5 going to 20? 4 times. So it's going to be 3 over. So what do I write here? How many x's are here? 6. There's 1, 2, 3, 4, 5, 6 x's. How many y's are there? 3 y's. 1, 2, 3. How many z's are there? 1. The denominator, what do I have? How many x's do I have? 3. It says 1, 2, 3. How many y's do I have? 2. That's being multiplied. And then how many z's are there? And let's cancel. X goes into x once. X goes into x once. Not so. X cancels x. X cancels x. No other x is cancelled. Not so. So what do I have thus far? 3 over 4. 3 over 4. X cubed. As you can see, there's 3 over 3. Let's look at the y's. Y cancel y, y cancel y. How many y's am I left with? 1. This is going to be y or y to the 1. Not so. Do I have to write that 1 here? No. What do you notice about the z's? Also cancelled. So do I have to write the z there? No. That's the answer. Okay. Now looking at this information now, these 3 examples, what do you notice? Okay, you did it already. Anybody else? What do you notice? How can we link x to the 5 over x to the 3 with x squared? How can we link? Okay, that comes from previous knowledge or previous topic. But what do we know about x to the 7 over x to the 4? Linked to x cubed. Yes, Michael? Can you all see that? You're minusing the exponents there. So let's look at the first one then. The first sum was x to the 5 over x cubed. Can you see that? So, in other words, we can simply say it's x to the 5 minus 3. And what's 5 minus 3? 2. Can you see that? Let's look at the next one. What if we had 2x to the exponent 7 over 4x4? Of course, 2 goes into 2 once, 2 goes into 4 twice. So it's going to be half x 7 minus 4. What's 7 minus 4? So it will be x3 over 2, which is the same as that. You all agree with that? The last one, before we go into the rule, we can say now that we've got 15 we've got 15 x6y cubed z over 20 x cubed y squared z. So 5 goes into 15 3 times, 5 goes into 20 4 times. So what do we have? 3 over 4. Okay? So what do we have now? X 6 minus 3. Y 3 minus. Can you see only with the same basis I can bring that together? And Z, if there's no number here, 1 minus 1. So that's going to give us 3 over 4. 3 over 4. X, what's 6 minus 3? 3. What's 2 minus 1? 2 minus 2? 3 minus 2? 1, which we have there as well. Can you see that, people? But here we have Z to the, what's 1 minus 1? 0. People, anything to the power 0 is 1. Because say for argument's sake, here was a 0 here. 0 times anything would have been 0, not so. But here is actually a 1 that's multiplied here. So anything to the power 0 is 1. So make a note of that. This now gives us an answer of, if that becomes 1, 3x cubed y over 4. Which is exactly as we have it. Yes, Michael?
So I have 2 questions.
Ask.
First questions are, for the first one, the example that you did.
The first example is?
Yes, sir. You wrote x over 5 with x 5 over x cubed is equal to just x squared. Do you not have to write that over?
So you're saying you want to leave that out?
No, I'm saying that would you not have to write that the answer over x cubed?
No. Because we have taken the cube into account. Sorry?
So you also take the exponents into account for the other questions.
How do you mean now?
Because like so you say that you take the 3 into account, but like for the other questions, like for the last one, for example, you also took the cube into account, but you still put the x. No? Wait.
This one.
So how come the other one isn't over x cubed?
It is over x cubed. There's an x cubed.
No, for the first one, sir.
This one. You're talking about this one.
Yes, sir. Why?
There's x cubed.
No, the answer.
No, but this cancel. And then you give me 1 at the bottom. So 1 times 1 times 1 is 1. If you look here, why did I keep a denominator here? Because of the 2. That's why I kept the denominator. The x's is gone here. You see, it cancelled out completely. Why did I keep this denominator here? Because of the 4. 4 times 1 times 1 times 1 times 1 times 1 is 4. You understand?
And so my second question is,
Okay.
for the last question that you gave us to do, I didn't do the middle step. You would still be
You went straight into the answer.
Yes.
It's fine. Okay. As we said, we're looking at this these sums here from the previous lesson as well. We didn't have to say there's going to be 15 m2 plus 5 plus 1. You see, I didn't show that middle step there to get m8. Okay? You are doing that in our mind. Likewise, here people, you could have gone from there 5 minus 3 and get x squared straight. You guys understand? Alright. So there, I want you guys to write down that rule. So therefore, you got x to the m over x to the n is equal to x to the m minus n. Will be always the top one minus the bottom exponent. So the rule says, in words, when dividing and bases are the same, so subtract the exponents. When dividing and bases are the same, you subtract the exponents. Okay. Make that note there, people. When dividing and bases are the same, subtract the exponents. Indices and exponents is the same in class. Okay, notation. We've got 10, x to the exponent 10 divided by x squared. This can be written as what? X to the 10 over x squared. And if we ask to simplify this, what would it be? X to the 8. Or I could have said 10 minus 2. Alright, you guys understand? So let's look at an example. Again, the examples are on page 30. So let's go with the first one. Write this down. You guys can do it quickly. We've got 2 to the 5 over 2 squared.
Good afternoon. May I have your attention, please? The following learners, if they can please report to the office. Kiara Kut, Inam Nkosi Miki Zwana in grade 8. Lisa Kanya Makiva, Jimpo Bembi, Iman Jardine, and then also the Christian Society will be meeting in the library now during break. Also grade E12s, I have a presentation for you in Mrs. Patel's classroom. If you're interested in higher education, please meet in Mrs. Patel's classroom.
Okay.
We have sports in store with the clothing shop. If you need to buy any of those uniform sports clothing, please see Mrs. Rennie now during second break.
Okay. So when you're dividing and bases are the same, what do you do to the exponents? You subtract. Are these bases the same? So it will be 2, 5 minus 2. And what's 5 minus 2? What's 5 minus 2? 3. And 2 cube is? 8.
Sir,
Yes.
I don't understand.
What don't you understand? Just hang on.
Sipusihlu Ketelo, Sarah Abdurrahman, can you please report to Mrs. Alod?
Okay, so what don't you understand?
Sir, I don't understand. Because aren't we supposed to cancel the
But now, if you got x to the 5 over x squared, what did you say this was? X squared. We didn't cancel the x's there.
Please report to the music block.
Did you cancel the x's here?
Sarah Abdurrahman.
No. So why do you want to cancel the 2's here? It will only cancel if there's no exponent there. Okay. If you got, say you got 2x5 over 2x6 or 15 and 6. Then the 2's will cancel because they're the same. Then you get x15 minus 6, which is x9. You see the difference? Okay. Just give me a couple of minutes and then. Okay. So number 2. If there's no exponent on this x, is a 1. So that will be x. 4 minus 1 is? 3. So any confusion there? Okay. Let's look at number 3. Okay, for number 3, 3 goes into 3 once, 3 goes into 6 twice. So what's 3 minus 1? 2. And B, 6 minus 4? Goes to 2. You guys understand? Again, when we're dividing as bases are the same, we subtract the exponents. Only the exponents of A can be subtracted and the exponents of B can be subtracted. You guys understand? Let's look at number 4. Number 4 we have, is there any number that can go to 3 and to 4 without the remainder other than 1? So it stays 3 over 4. So the x5 over x1. So I subtract 5 minus 1 is 4. And a 1. Okay. Look at the next one. 2 goes into 2 ones, 2 goes into 4 twice. So it's 1 over 2. So here we got x10 over x. So it's 10 minus 1 is 9. So it's x9. We got y cubed over y squared. What's 3 minus 2? 1. So it will be y1. And the z's are the same, so they cancel out. Otherwise I can say z is 1 minus 1, which is z to the 0. This can also be written as, without that 1 and that 1 there, x9y over 2. Or I can write it as 1 over 2 x1. All of that in the exam, you'll get the full mark for it. Okay? The last sum here, number 6. Look at this, 10 goes into 10 once, 10 goes into 10 once. Not so. P squared, cancel P squared because it's the same. And Q squared cancels Q squared. So what's the answer? 1 over 1, which is 1. People, for homework is exercise 2 on page 13. People enjoy the rest of your day. Good morning class. Good afternoon class.